Okay, I will send you a link to the Desmos graph that creates this picture here, so you can see how to maybe do this problem on Desmos. But here's the diagram. We're starting at the marina, which I placed at the origin. Since we're going, what are we going? 40 miles per hour per kilometers for 3 hours. We're going 120 kilometers to point A, due east. And then we go south 22 degrees west, which leaves 68 degrees for this angle right here. And we're traveling in that direction for 60 kilometers because we're going 2 hours at 30 kilometers per hour. And so we do know two sides and the included angle. There's the law of cosines right there. You can also create this circle on Desmos, find the point of intersection of this line and the circle, which is this point B up here, and then use Desmos distance formula or function. And that confirms that looks like we got the right answer. Now, the question that remains is how do we find the direction that the guy from the marina has to travel? Well, we have to use the law of sines to get the size of this angle, which here's the law of sines right here. Sine of angle M is to its opposite side, which is 60, as the sine of 68 is to its opposite side, which we found to be 112.27. And we solve for M this way. So there's the measure of angle M, 29.7 degrees. Now, how do you specify the direction? Well, you can use bearing, which is how many degrees clockwise from north. That's one way to say it. We can say the bearing is this 90-degree angle plus 29.7. So we could say the bearing is 119.7 degrees. Or you could use a direction and say this angle right here is 90 minus the 29.7, which is 60 degrees, 60.28 it looks like. And so you could also say that his direction will be, he's got to head south, but then he's got to go 60.28 degrees east. That's another way to say it. Okay, so bearing is 119.7 degrees. That's always clockwise from north. And the direction is south, 60.28 degrees east. Okay, there you go. Hope that helped. I will post a link to this Desmos graph so you can take a look how I got the equation of this side and, of course, the equation of the circle.